All right, we're back for problem 6.10. And it's an example of a binomial probability distribution. So right over here on the right hand side of the screen you can see that the probability of X successes in a binomial experiment with n trials and probability of success is equal to P is, and then it gives you this nice little formula. So remember, when we're talking about binomial distribution or a binomial experiment, it has the following properties. It's got a fixed number of trials represented by n. So in this case, we're looking at a sign on a gas pump for a chain of gasoline station stores that says the encourages customers to check their oil, claiming that 1 out of 4 cars needs to have oil added. So in A, the example is we're going to have n trials, 4 trials. 1 should need to add oil, which would be success. So that's X. And then the probability, it says that 1 out of 4, so the probability is 0.25. And the other thing to keep in mind with a binomial experiment is that the trials are independent, which means that the outcome of one trial does not affect the outcome of other trials. So we've got this big formula over here. What I've done is broken it down. So the first thing we want to calculate is n factorial. So the way we do that is we go equal and then type FACT, which you can see here returns the factorial of a number equal to 1, 2, 3, whatever. So I'm going to double click here and it's going to be 4. So I'm going to click on cell C1, close the parentheses and check it. And in this case it's going to be 24. So if you go, in this case 4 factorial would be 4 times 3, which was 12, times 2, which is 24, times 1, which remains 24. And now we're going to do it for X. So it's going to go equal, and again we're going to go fact, double click. I'm going to click on C2 because it's X factorial and the X in this case is 1. Close parenthesis, click the check mark. And now we're going to take n minus 1 and do the factorial of that. Now in this case, I'm going to go equal, I'm going to do parenthesis and go n minus x, which is C1 minus C2. Oh wait. I should have done that actually. Fact. So 4 minus 1 factorial, 3 times 2 times 1 equals 6. And now, in this case, we're going to take the probability to X. So in this case, it's going to be equal to C3, which is the probability, and then use the little thing above this, the capital on the 6, that caret there, and then we're going to take that to the power of X, which in this case would be 1. Click enter. And again, that's the probability of success. The probability of failure, in this case success is a car needing oil. The probability of failure is going to equal 1 minus P, close parenthesis, and then we're going to take this, take it to the power of n minus x. So again, n minus x. Hit enter. So that gives us the 0.421875. And now what we need to do is actually run this calculation. So here's what I'm going to do. I'm going to go equal to, and then the value of n factorial, divided by, and I'll put this in parentheses, x factorial multiplied by n minus x factorial times px times 1 minus p to the n minus x. And once I've done all that, calculate it right there, it gives me 0.421875. Now there's another way to do this calculation, and that's to use the binomial function equals binom, and it returns the individual term binomial distribution probability. So I'm going to double click here, and it tells us what we're looking for here. So the first thing is n, the number of trials. So we're going to click up here. Oh wait, I take that back. It would be the number of success. So we don't want, we want the x. And then comma, and then the number of trials, which is in C1, comma, and then we want the probability of success, 0.25, and in this case we have to indicate whether it's cumulative or not. In this case we're going to put false, close parenthesis, click enter, and you can see that I pretty much matched that. Now if I went over here and adjusted this just a little bit and showed one fewer decimal, we get a match right there. So that's the first case for trials with one success. Now for part B, we've got 2 out of the next 8 cars. So let's do that down here. This is B. And we've got it set up so it goes equal to fact, double click there, and it's going to be 8 factorial. So this is going to be quite a large number, 40,320. And then we're going to do it for equal the factorial for x, which is going to equal 2. And then we're going to go equal factorial, and in this case we're going to go n minus x, hit enter, and we're going to do the probability, which is still the 0.25, and we're going to take that to the power of x, which is squared there, hit enter, and now the last thing we want to do is equal to 1, I'll put that in parentheses, 1 minus the probability, so it's going to be 0.75, basically is what that calculation is, and to the power of n minus x. And so now I can go over here and do that same kind of calculation again. In fact, if I just copied this formula and put it right here, it'll give me that number. Because basically now watch what happens. it's taking the n factorial divided by x factorial times n minus x factorial times the probability to the x times 1 minus the probability to the n minus the x. And again, if I wanted to do this with the binomial function, just binom distribution, double click there, and the number for success is C14, which is 2. The trials is 8. The probability is still 0.25, and it's still going to be false. And you can see that I get the match there. And again, it's important to go through and show your work here, because if you happen to put something in wrong just using the binomial function, then I have to assume that you really don't understand it. Where if you show me the work and how you did it, even if you did a minor miscalculation, I'll be able to give you more partial credit, because I'll be able to see at least the flow of how you did the calculation. And we're going to do it for the last one here, which is for 12 trials. So again, equals fact 12 equals fact 3 equal fact n minus x, and then we've got equal to p to the, in this case, third to the x, and then we've got equal to 1 minus p to the 12, or n minus x, 12 minus 3. And again, I'm just going to copy this formula down because everything's in the same position. And if I use the binomial function here, and I'm running out of time, that's why I'm hurrying a little bit. So we got 3 for success, the number of trials 12, the probability 25 still, and it's false. And you can see that that lines up. So again, make sure you show your work. That's it for 610.